Hey, what's up everybody? Fuller here. Welcome back to the channel. And in today's video, as promised, we are going to do a deep dive of my drum synth sequencer that I built in the Unreal Engine 5.1. And it looks a little bit like this. So this project here was really kind of inspired by this TD3. This is the Behringer TD3, and it is a clone of the Roland TB303, which is a bass synthesizer used a lot in acid music and house and stuff like that. But it's basically a mono synth that you can program, a bass line basically, or a melodic line. And then I also wanted to use a old school kind of drum sequencer kind of thing where these four balls basically represent, these four spheres represent each beat of the measure. So this would be beat 1, beat 2, beat 3, beat 4, and you can turn them on and off. So each measure, like a traditional drum machine, it plays on that beat. Each of these instruments has a 4-beat sequencer on it, and that turns them on and off. And then of course the synthesizer plays a bass line that's kind of randomly generated, and we have tempo things here. Well, I'll get into that in a minute. So the purpose of this is to kind of experiment with a couple things. One, I wanted to see how far I could push the boundaries of the quartz clock and how much we could manipulate tempo but still keep the Metasounds in sync, which was very successful in this project. And then also being able to play quantized, play the different beats quantized on, as well as using 3D interaction to manipulate the Metasound. Basically, I wanted to turn on and off parameters of the Metasounds, but I didn't want to use a 2D widget. I wanted it to be more like a playable game. So essentially, that's what this is. This is basically a game that we built, and the game is basically just kind of pushing to kind of see what you can do with the Metasounds. So one of the main reasons I built this was, for one, I wanted to push the boundaries of the interaction between the Metasounds and the quartz clock. And the other thing is I wanted to figure out ways to use 3D interfaces to manipulate the parameters of the Metasounds. I didn't want to just use a 2D widget, but I wanted to use something more like you were playing a game. So this is, in essence, a musical game, basic at its core. However, took a lot of scripting to kind of figure out how everything works together. I want to talk about the layout, the physical layout, and then this video could be really long, but I don't want it to be really long, so I'm not gonna rebuild this from scratch. Otherwise, this would be a 4 or 5 hour video. But what I do want to do is I want to give you an in-depth walkthrough of all the blueprints, all the Metasounds, so that if you want to build something like this, you can do it yourself as well. If you're new to Metasounds, please go back and check out my Metasounds 101 video or my Metasounds Synthesis series video, because that will kind of get you up to speed in some of the techniques and stuff that we're using here. If this is your first video with Metasounds in the Unreal Engine, it's gonna seem a little overwhelming, but take heart. If you go back and watch the other videos, you can get caught up pretty quick. So let's look at the physical interface. Now, in here, it's basically we're actually outside. All I have is a wooden platform here. I did spend a little time with the lighting because I wanted it to look cool, and I wanted to look a little bit kind of not steampunk, but more like carnival. So I brought in some lights and things like that, but that's not really important to the functionality. I just like to do, cool, fun looking stuff. Essentially what we have here is we have 4 metasounds. We have the synth metasound, the kick, the hi-hat, and the snare. Then we have these 4 boxes which just represent them. These boxes essentially aren't really doing anything other than when you click on them, it does activate the metasound, and we'll show you more about that when we look at the blueprint. Above each of these boxes, we have 4 spheres. Now these spheres are important because these spheres are going to be used to trigger different different metasound parameters. And again, that's how we kind of like communicate with the metasound. We have 2 buttons here. One is the BPM up, one is the BPM down. When you click on those in the game, it bumps it up or down 4 BPMs. Because again, I wanted to kind of test the real-time reaction. So you essentially have 4 metasounds playing at the same time, all on quantization boundaries with the Quartz clock, getting real-time adjustments to the BPM. And so that's what I really wanted to push on this demo. Then over here, we have a couple of cool knobs that I built here. This is the filter knob for that controls the synth filter, which is just a ladder filter, and then this is the volume knob, which controls the volume of the synth. So that's kind of like the layout. Not a whole lot to it, but I also want to kind of show you the 4 main things we're using. You know, we're doing most of this logic inside the level blueprint. And so if you click over here and you open the level blueprint, you'll see all of this logic that's happening. Here's kind of like an overview. There's a lot going on here, and we'll deep dive this in just a second. And then we have the metasound for the kick, the snare, the hi-hats, and then the synth pulse, and we'll look at that as well. Other than that, that's kind of all that's happening here. I did put all of the logic in the level blueprint. As I was experimenting with this, it just seemed like the right way to do it for this. Some of my other videos were talking about using this event dispatchers and things like that. So in essence, I haven't really landed on the best way to do it for this type of stuff yet. I'm kind of still in between. So I've done a little bit with the level blueprint. I've done some with event dispatchers from different blueprint instances. And so I'm still kind of working on that. All of this again is kind of leading up to my Metasound, or my steampunk mono synth that I'm building. So just experimenting. And that's one thing that's kind of wise to do, I think, is when you're working in the Unreal Engine, is to do smaller projects to figure out techniques as you work towards a bigger project. And then that way you're accumulating skills. And that's really anything in life, is just learning the basics and the skills and then building upon each of those. It's definitely a cumulative thing. So here we're going to look at the metasounds. We've got the kick metasound, snare, and hi-hat. Now I will say this, the kick, the snare, and the hi-hat metasounds are pretty much identical in their functionality. They're just using different sounds. And then the synth metasound is a little bit different. And I had to I'll show you a couple things I did with that. But first, let's just look at the kick. And for the kick, what we have happening here, we have our main wave player here, which is just a basic wave player, and it's playing this kick sound. Okay. Now, how it's playing that kick sound is when you start the meta sound, nothing happens. Okay, and that's important because we wanted to start the meta sound on the Quartz clock, but we didn't want to hear anything. So right now it's playing, but you don't hear anything. And the reason why is because we're going to use this input trigger on start to start this trigger repeat, and it goes like this. So you see that it's going 1 through 4, and then it's closing that trigger sequence. So what we're doing here is we're basically sending out 4 pulses on this BPM. Now, this is important, and we'll look at this in the level blueprint. This BPM is a parameter variable that's being sent globally. So in the level blueprint, that when you click on those buttons, that's what sets the BPM in the level blueprint, and then the level pushes that BPM information to all the meta sounds. So all of the meta sounds on every tick are getting BPM updates, which allows us to do these tempo changes in real time. It's here, it's defaulted to 90. Honestly, it doesn't even really matter, because once you start the game, it defaults to 90, and then you can move from there. So if you remember in my Metasound 101 video, we talked a lot about these triggers, and I just want to go through them real quick. So when you hit the start trigger, which we created by dragging off of here, we are doing a trigger repeat with the BPM information. And then on each of these pulses, we're going into a trigger sequence. And what this does is every time it triggers a repeat, it goes through the sequence. It goes 0, 1, 2, 3. And then if this loop is clicked, it will continue to loop. But we don't want that. We want to leave that off, and I'll show you why in a second. But we leave this off. So basically when we hit start, it plays through at this BPM, whatever this global BPM, and it goes through 0, 1, 2, 3. And what we're doing here is that is representing the 4 beats, those 4 spheres. That's representing each of those beats. Because we have it over here on the beat multiplier, this is 1 beat for every 4 beats, right? So we got 1, 2, 3, 4. Now here's something to notice. These triggers are going out, but we're using this trigger control because, and this is really important because this is going to be how we toggle on and off that beat. So right here you see it says start closed. What we'll do is when we trigger the spheres in the level blueprint, it's going to turn that to open. And then when that's open, you're going to hear sounds go through it. So let me just open 1 and 3 and then see what happens. So now you've got beat 1 open and beat 3 open. And this is the core of the logic for the sequencer. So essentially what we're doing is when you click on one of those spheres, if you click on the first sphere, it's opening this trigger. So all of these beats are playing, but you're only hearing the ones that are triggered open. And so if I open all of them, you'll hear basically a 4 on the floor. And then it stops. And the reason it stops is because we're using a quantized delegate to start this. So this is basically starting over every measure. Okay, so that's kind of how the kick, the snare, and the hi-hat work. So we're going through the trigger repeat, we're sequencing it 4 beats, and then we're deciding which beat we're going to allow that trigger to pass. When that trigger passes, it goes into this trigger any. And what the trigger any does is it basically takes any trigger and it plays this wave, which in essence is this kick right here. It's playing that. Now, we could use multiple kicks, and I'll do that in future videos, but right now we're just playing the same kick over and over. You could send each of these triggers out to a different sound if you wanted 4 different kick sounds. So if you wanted each kick beat to sound a little different, you could do that. But for the sake of demo, I left it at 1. So that's how the kick drum works. Snare drum, same exact thing. We start the meta sound. As soon as we hit start, it cycles through the trigger. All these are closed, but when we open them, we're going to hear the snare. Same concept, same principle. Let me remember to close these. Now here's why I close these, because if you start with them open, then the whole song's just going to be playing like crazy. So you want to start with them closed, and you want to make sure the loop is off. So that's the same for the kick, the snare, the hi-hats. Now let's look at the synth meta sound. The synth meta sound is a little bit different, because now with the kick, snare, and hi-hat, we're using audio files. But again, the whole purpose of this was to experiment with mixing audio and synthesis. The Metasounds Synthesis engine is very powerful and it's very cool. And if you check out my Metasounds Synthesis series, you'll see kind of how we did some subtractive synthesis, some FM synthesis. But this is the basically the saw wave. We're using a saw wave. And let me just walk you through this, because this is a little complicated, and it took me a while to figure out how I wanted to do this. But the way I wanted to do this is I wanted to play 32 notes. I wanted every time this synth triggered, I wanted to play through 32 notes, just like the old synthesizers that we use to do step sequencing. And so the way this works is, let's just go from the left to the right. All right, so we play the meta sound, you hear nothing. Again, we wanted to be able to start these meta sounds so they're queued up in time, and then we can turn them on and off as we want. When we hit start, okay, we're at a slow tempo, which is good, so you can hear it. When we hit start, we're gonna start this trigger repeat. Same concept as the audio, except what we're doing is we're just playing Now, if you'll see here, instead of playing on beats, quarter notes, we're actually playing 16th notes. So that's what this is. We're dividing the whole note by 4, and we're playing 1/4 of that. So we're actually playing 16th notes. So this is 4 times faster than the kick, snare, and hi-hat, and that's important. So what's going to happen is we're going to go over here. We're going to start the trigger repeat, okay? And then we're going to start counting the triggers, because what I want it to do is I want it to play through 32 notes, and then I want it to stop. And so that's what happens. Let me speed this up a little bit. So there you go. So every time I hit start, it's going to play through 32 notes and then stop. Now you'll see on the trigger counter, that's how we're doing that. So we're triggering it, and we start counting. First one is 1, 2, 3, 4, all the way up to 24. And when it gets to 24, it closes this loop on the sequence, and then it plays through one more time. So that's how we get to 32. We set this at 24, it closes this loop at 24, and then it stops. And then we have to re-trigger it to get it to play again. Now, otherwise, there's no real way to control it. You just start it and it just goes forever. I wanted it to happen in 32 note blocks. So we've got this trigger counter counting the triggers, and then again, every time that this plays, it sends a trigger sequence out, and this is what's triggering the notes. You can see it running through it. It's trigger this out. It says 0 through 7, but remember 0 is actually 1. So this is an 8-note trigger sequence. So it plays through 8, then it plays through 8 again, and it counts. When it gets to 24, it plays through 8 one more time, and then it stops. What this trigger any node allows us to do is it allows to take all of those sequence outputs, and instead of sending them to a bunch of different spots, we can send it to one spot. And that's this random float right here, because this is important. This random float is what notes we're actually hearing. So every time this triggers, we play a random note to the saw wave. And if you'll see here, I've converted this note from MIDI to frequency. So what we're doing is we're playing the note 32 to 38. So MIDI note 32 to 38. So when I hit play and I start the sequence, it's just generating random notes from here, which is super cool. And it gives it that kind of like Blade Runner vibe, which is cool. I also am running this through a really quick filter, just something really quick. You can actually adjust this if you want it to be slower, but because I wanted to push it to a quick tempo, I wanted to leave the attack and the decay really quick. The other thing is we're coming out here. Here's our filter, which is attached to the knob that we move in the blueprint. And so basically when we start this, that's controlling our Metasound filter for that synth, which is super cool. We got a ladder filter coming in here with the cutoff frequency being determined by the variable. Then we've got volume control, and that is pretty much the synth Metasound. So again, if this is kind of overwhelming, if you go back and watch my synthesis videos, you'll get up to speed pretty quick. So that's all we need for the Metasounds. Now, the rest of this, all of this action is happening inside the level blueprint with blueprint scripting, and we're going to jump into that right now. Okay, so let's look at our level blueprint overview. Okay, I'm going to break this down into 6 quick sections. Okay, the first section is the mouse interaction. Again, I'm not going to build this from scratch because this would take forever and nobody would watch it. So I'm just going to walk through this. So if you want to rebuild it, you can pause the video and look at the blueprint to see what's going on. So we're in our level blueprint. We've built all this. We've put our, oh, by the way, let me just kind of show you real quick. So if you look at the boxes, so this is BP kick. If you look at this, literally all we have is this box that I wrapped with a cool image of a kick drum. That's all. Nothing happening, no scripting or anything going on inside this. So that's literally just a cube. And then for the spheres, same thing. We're just using literally a static mesh of a sphere. And I'll show you, when you click on them though, they do change colors and then they do have emitters. And I'll show you, that's all in the level blueprint. That's all happening in the level blueprint. Okay, so over here, first thing, this is really important. We have to enable the mouse interaction. Okay, so as soon as the game starts, we need to set enable click events, enable mouse over events, show mouse cursor, and then enable input, get player controller as your target, on event begin play. If you don't do this, you won't see the mouse and you won't be able to click on things the way we want to click on, because here's the thing. The way we determine, so when the way these knobs work, so all of this stuff here is just click and play. That's all that is. However, and the same with the BPMs. However, with the knobs, what we're doing is we're using a line trace. So we're using a line trace to select that knob, and then we're using Z and X to animate the knob and send Metasound parameters. So that's why we need mouse input, and we need to see where the mouse is. So important, don't skip this part. If you want to be able to use the mouse, we want to get, again, we're just setting the parameters for enable mouse over, enable click events, and show mouse cursor. Okay, now you probably wouldn't have to do this if it was already set as a, what do you call it, a preference, but I'm just doing it just to make sure it works. Now, next thing is we want to look at the quartz clock. Now, I have a previous video on how to set up a quartz clock. Go check that out if you've never done that, because that can get a little bit complicated, but I'm just going to show you real quick. On begin, this is coming from event begin play. We're creating a new clock. We're setting the time signature to 4/4. We are setting the BPM of the clock. Now remember, this is a variable because we want to be able to control that inside the game when we manipulate it. So right now it defaults to 110. I did say 90 earlier. I was wrong. It defaults to 110. If you want it to default to 190, you can just click on it there. So that's our main BPM parameter. And again, the way you create these is you just drag off here and you promote to variable. And then over here, you'll get these variables and you'll be able to, there's our BPM, it's a float. Then after that, we subscribe to the quantized clock and we create this event delegate here on quantization event. What this does is basically once the clock starts, this event happens on every beat, because that's what we selected here. We have it happening on every beat. Now, the other thing I wanted to do is I wanted to visually see where the quartz clock was in the transport. So we did some print strings off of bar number and bar beat. And so we're print stringing this out. And then that way when we see this play, you'll see in the right side of the screen, there's our quartz clock. That's the measure and beat. 3, 4, 4, 2, 3, 4, 5. So that is where the quartz clock is. It's handy to be able to see that. Now, I wouldn't have that playing if this was a game, but I like to be able to visually see it and see how things are working. Then over here, we're setting this variable called quartz clock, which we're going to need for various things. And then here we are starting the clock, which essentially starts all of those functions. Now let's look down here as well. This is a reset transport. I don't have it active right now, but if you wanted to, you could drag off the bar numbers, and then after the 4th bar, you could do some branching here to reset the transport, which would make that quartz clock after the beat 4, it would go back to 1. And that's kind of handy for looping and musical ideas, but we're not going to use it now. We're just going to let the quartz clock run to all eternity. Then the other thing is, and this is important, this is where we're going to essentially load the Metasounds and start playing them. Because remember, with the Metasound, it has to be playing before you can use these triggers. So if it's not playing, you can't access this trigger. So what we're doing in this step is we're creating the Metasounds. We're bringing in the pulse, the synth pulse, the kick, the hi-hats, and the snare. And we are actually going to create variables on those as well, because we want to store that Metasound as a variable. And so that's what I did here. I create the Metasounds synth pulse, which you just do by clicking on and finding the one you want to start. You see I have 4: kick, snare, hi-hats, synth pulse. That's why there's 4 here. We got the synth pulse, kick, hi-hat, snare. Now we create the Metasound synth pulse and we store it as synth Metasound. Okay. And then over here, same thing. We're creating the kick Metasound. We're not creating it. We're basically kind of like populating it into memory And then over here, you'll see we're playing kick, snare, and hi-hat. So kick, snare, and hi-hat are going to play as soon as the quartz clock starts, because we want to be able to turn on those beats at any point with on the correct metronome. So we create these 4 sounds. Notice we're not playing the synth sound yet. The reason I did that is because I wanted to be able to click on the synthesizer icon to start the synth track. So we've loaded that, we've created that meta sound in the game, but we haven't triggered it to start yet. These, however, we are triggering to start. So as soon as the quartz clock starts, it creates the kick, snare, and hi-hat, and it stores them as variables that we can access them in other places in the blueprint. And then it starts playing all 3 of those, but you don't hear anything. Why? Because even though it's playing, we haven't triggered this start trigger yet. So keep that in mind. So that is the quartz clock and loading of the meta sounds. Now let's move on. Okay, so that's up here. Let's move this up just a little bit. Okay, now the next part I want to look at is the line trace that we're using to control the faders. Now, I wanted to be able to use 2 buttons for any fader. So X bumps it up, Z bumps it down. If I click on the filter, it bumps up and down the filter. If I click on the volume, it bumps up and down the volume. And essentially, we could make as many faders as we want. By using the line trace, what it does is it allows us to go, okay, we hit something, what did we hit? And then we can send those controls to that fader. And that's really important. Otherwise, you'd have a bunch of faders doing a bunch of random different things. So let's look at the line trace logic. So what we're doing here is, again, this is all in the level blueprint. And I'm talking fast because I don't want this video to be too long. But in this line trace, what we're doing is when we click on the right mouse button, okay, we are starting a line trace by channel, okay? Where are we starting it? Well, we're going to get player control and we're going to convert the mouse location to world space. And again, this is why we had to show you where the mouse is in that beginning step, because now when I right click, you see that line trace and it hits that button, or if it hits that actor, or it hits that actor. And that information is what we're going to use later, to determine what to control. So we convert the mouse to a world space, and then what we do is we send out a literal float. I just put 10,000 so it goes really far, and that's going to send the line from where the mouse is relative to the world space. Then from that line trace, we're coming out of here, and we are getting this we're breaking this hit result. The reason we're doing that is because I want to get this hit actor. I'm going to take this hit actor and I'm going to set this parameter variable as hit actor. So now I can, at any point, I can get what got hit. So whatever I hit, it's going to change that hit actor. So if I hit a box, it's going to change hit actor to a box, which means none of the other logic for the faders will work because it's a box, it's not the fader. Once I get that hit actor, I am getting the display name of that actor. And again, this is important because these display names, filter cutoff or volume, you see over here, volume, those are the display names. So we're getting that name. And then over here, and this is important, I'm setting the Boolean state because I want to know, did what I hit, if I hit something, is it a filter cutoff? Is it volume? If not, then none of our keys aren't going to do anything. If it is, then you'll see in a minute, it's going to actually do something. It's going to control that. So we come over here, we Boolean is volume or is filter. So we're setting these variables. And again, the way you do that, so you can just go over here. Let's just see how you create a variable. You right click and you go is EQ. Let's just say it's is EQ. And then once you have that filter or that variable, you can just bring it in here. You can either set it or get it. If you set it, it's going to give you this box. And then you can do whatever you want with that box. If you get it, it's just going to get the value of it, whatever it is. So that's important technique to know in this. So here, every time we do a line trace, it's either going to be filter cutoff or volume or nothing or something else, right? So if it's filter cutoff, this is true. If it's volume cutoff, if it's volume, that's true. So that's how our line trace works. Okay, take a breather. pink drink. It's really good. All right, now let's look at the tempo. Here's how the tempo works. So what we have here is we have these two boxes, BPM and BPM. I spelled it wrong because I was in a hurry, but PBM, it should be BPM. So the way you get this is you click on your object, you go over here, and then you right click, and you can create a reference to that thing. So there's our BPM button. Or you can do a call function or a add event. You could do collision. We're doing on click. So under input, mouse input, on click. And it's already in here, so it's not going to do anything. It's already here. So that's how we get this node. From here, we are setting beats per minute, and our target is the Quartz clock. So again, now that we have this is why it was important to store the Quartz clock as a variable. So we can drag this in here, get Quartz clock, and then we can drag off this, and we can set BPM. And that's how you set the BPM of the Quartz clock in real time. So every time I click on this, it's going to set the BPM. Now, what's it going to set it to? Well, here's what it's going to set it to. We're going to come out of Quartz clock, and we're going to get BPM, because we need to know what the BPM currently is. So if the BPM is 110, now we have that information, and what we're going to do is we're just going to subtract 4. So we're going to go over here with the subtract node, or it's an add node, and we're adding -4. And then what we're going to do is whatever that answer is, so 110 minus 4 is 106, then we draw this into here. So now what we're doing is we're setting the BPM just 4 less than whatever it was. So we also, after we set the BPM of the Quartz clock, which is the clock itself, we also want to tell the blueprint that now the new tempo is this thing. And that's because we're going to feed that information to the Metasound. The Metasound isn't going to get the Quartz clock information directly. You have to tell it what it is. So we're coming out here, we're setting beats per minute. So now we've adjusted the Quartz clock and we've set that to the new BPM. Then we come out here, and I just did this. I got the new get beats per minute because this is after this node. I got the new one, and then I'm printing it because I just wanted to see what the tempo is. So now when you look at this, here's when we press this, you see the new tempo: 110, 106, 102, 98, and the same with up. Up is just the opposite. The only thing we're doing with up is everything is exactly the same, except we are using a different button, and then we are also adding 4 instead of subtracting 4. And this is why getting the current BPM is important, because you got to get the current BPM so it knows where to go from there. Otherwise, you'll just always be setting the same tempo. So you got to get the current tempo, add or subtract, and then set the new BPM. Now, once we do all that, this is how the logic in the actual Metasounds work. These are real-time BPM updates. So on every tick, because this is important, because you need to update the BPM every single tick so that it knows, okay, now we're at 108, now we're at 104, now we're at 100, whatever. So this is the only node in the whole game, if you will, that's using the event tick, I believe. So, because I know it's not, you don't want to always use event tick because it happens on every frame, but for this, it's, this is the whole purpose of this. So we're event ticking. We're setting the float parameters, okay? And again, this is why we use these, this is why we stored the Metasounds as variables. So we're coming over here, we draw this, we get kick Metasound or whatever Metasound we want, and then if we drag off that, we can set the float parameters. Again, you learned all of this in my Metasound 101 video. We are setting the synth Metasound, we are setting the kick Metasound, hi-hat Metasound, and snare Metasounds. So basically, our 4 Metasounds, we are setting in the BPM, because all of these have remember, a BPM input that we created. And then we are using this variable, right? The newest, most up-to-date BPM is now going to these Metasounds. So this is how we're pushing the tempo to all these Metasounds in real time, so they will adjust instantly to the tempo. All right, take a break. Okay, now let's look in how we actually trigger the instruments. We have 4 instruments. We have the kick, hi-hat, snare, synth. Kick, hi-hat, and snare all work exactly the same. The synth is a little different. So on the kick, here's what happens. So we've got this box here. We'll come in here, same thing. We can get a reference to that, which is our BP kick. This is the actual box of the kick drum. This is the only thing we do with the box. We have to click on that box before we can hear the kick drum. So I can turn all these on, but we don't hear anything until I click this box. Now we have the kick drum. So that's how this works. You have to click each box to activate the kick. And the way this works, we click on the box, okay? We get the Quartz clock from over here. You can just drag this over here and get Quartz clock, and that's how we get that reference to the Quartz clock. We subscribe to the quantization event at the bar. Again, talked about this in my previous video on Quartz clock. There's a 2-part series out there. You can check that out. I'm not trying to promote my channel. I want you to have the information that you want. It might sound like I'm trying to promote my channel, although I do appreciate the views. But I just want you to know where to get the information because I'm going really fast here. So we're quantizing on the bar. We are creating a custom event, and then in that event, we are triggering, okay, this is the execute trigger parameter. What are we triggering? We're triggering the start node, if you will, in the kick Metasound. So when we click on that box, we're triggering this trigger from the kick. And if you remember, the Metasound's playing, but until we hit that, we won't be able to play the triggers. So that's how we're starting the track. Same goes for the hi-hat. Same goes for the snare track. Now the synth is a little different. The biggest difference with the synth is that we're actually playing it and then triggering start, and then we're doing that over and over and over again. And again, the reason I wanted to do that is because I wanted to generate random notes, and I didn't want it to run forever. I wanted it to run in 4-bar patterns. So over here on the synth, same thing. We click on the synth icon and we go over to the blueprint. You can right click, get a reference to that, which is the synth image, and then, or you can do the on clicked, which is what I did. So when we click the synth image, again, we get the Quartz clock from over here. We bring that in, we subscribe to the bar, and then we create the event. And now this time what we're gonna do is we're gonna play the synth Metasound, because it's already loaded. We're gonna play the synth, and the main reason that is different is because with the synth pulse, we're playing it, but until we hit that start button, it's not gonna do anything. So if you remember up here, when we first started the track, we actually loaded the synth sound, but we're not playing it. It's just a slightly different way to do it. So we're gonna play the synth Metasound, which is basically the equivalent of pressing that button, and then immediately we are going, because it's already loaded, it's already quantized, we're going to execute the trigger parameter called start, which is this one right here. We also have a stop on the synth if we want to use that, but we're not using that. And so that's how the synth track starts, and it just starts generating random notes. Now, let's move on to the animation of the knobs. And this isn't critical to the operation, but it does look cool. When you do the line trace, then you can use Z to go left and X to go right. So what happens here is every time we press Z or X, it's going to go through this sequence. And what the sequence is doing is we're basically playing a timeline of for volume, and we're playing a timeline for filter. And again, this is where the is volume, is filter booleans at the beginning of the blueprint are important, because what happens is when we press this, it checks, is it volume? And if it's volume, it's gonna do these two things. We're going to go to this timeline and we're gonna play this timeline. And what we're doing with this timeline is we're actually setting the rotation of, again, this hit actor variable. So this is why we need this hit actor variable. So whatever the hit actor variable is, if we hit the filter and it is the filter button, this variable becomes that actor. And so now we can change the rotation of that. And what we're doing is we're actually changing You can see here we've got the way that we got this logic set up. We've got the new rotation, the Y and Z stay the same, but the new X rotation is set on the timeline, which is just a 1.5 second timeline. Yeah, so we're going from 10 to 170 in 1.5 seconds. And what that's doing is that's rotating that knob that way. The other thing we're doing is, and this is how we're going to send that to the Metasound. Now again, this will only work on this fader if this hit actor is that fader. If this hit actor is not that, if it's anything else, this logic is null. It doesn't do anything. So we come over here and then we clamp this. We're clamping 10 is 1, 170 is 0. So that's basically the volume of the synth, and it's going from all the way on to all the way off. And again, we're pulling the variable from the synth Metasound over here, and we're setting the float parameter of volume, which again is over here. We created this in our Metasound way over here, right here. It's controlling that parameter inside the Metasound. For the filter, same thing. If that if the Boolean is filter, so when I do the line trace, if it's the filter, it's not going to go through this branch, it's going to go through this branch. We're going to run this timeline, and this timeline, same thing as 10 to 170 because it's the same type of knob, but this time it's going to go to the filter parameter, which is here. And that's going to allow, so we got two knobs doing pretty much the exact same thing visually, sending the same numbers, but we are sending it to a different parameter of the Metasound. You'll also see here, I changed this clamp range. So 10 is now 300, which is 300 hertz, and 170 is 1500 hertz. So that's how the filter sweeps. We're sweeping from 300 to 1500, which gives it that kind of classic ladder filter sound. Break. The final piece of the logic is toggling on the beats. So with this, these are each of the beats. So this is beat 1, beat 2, 3, 4. If I want 4 on the floor, I can go there. Maybe I want kick on 1 and 2 or 1 and 3. Maybe I want snare on 2 and 4. So the way this works is we had to come up with some logic here. Now, the way we do this is we basically brought in all these spheres. These are all 12 different spheres. Click on the sphere you want, you right click. Again, you can create an input on begin cursor over whatever you want. Whatever you want to trigger it. On this one, we're clicking it. Now we're flip-flopping this because again, this is an on and an off. So when you click it, it turns on, click it again, it turns off. So the flip-flop made the most sense here. We flip-flop to set the material. So what we're doing is we're defaulting to chrome, right? But when we click it on, it turns to gold. Just because I liked that visual, you know, I liked having the visual of clicking it on, clicking it off. So we're just changing the materials, which gives it the look of turning a button on. Again, here's our sphere. So what we're doing is we're setting the material when we turn it on to whatever this is. So when we first turn it on, we set it to gold because that's our on color. And then when we hit it again, we set it back to chrome because that's our off color. Remember, you do need to bring in the references to these, otherwise it won't know what material to set. So we're setting the material of the static mesh of each sphere to that. Now, in hindsight, I should have probably just did one blueprint and did instances of these. But again, just after I built it, I didn't want to go back and change it all. My steampunk synth will use blueprint instances instead of all this. So that way we wouldn't have all this freaking logic all over the place. But it is what it is. I didn't want to go back and spend time doing it because it works. So over here, the other thing I wanted to do is I wanted to spawn this cool emitter. I don't know, I just like the interaction's cool. So we added the spawn emitter at location, the world location of that sphere. We scaled it back a little bit so it wasn't too Michael Bay. And then that's what, so when we click on the sphere, it has that little explosion and that smoke looks super cool up against that dark background. So I like that. Then the final thing, the functional piece of this is we execute the trigger parameter on the kick metasound. So again, you bring out your metasound. This is why we stored this as a variable. Otherwise, we'd have spaghetti all over the screen. Kick metasound, we target toggle 1. Why? Because here in the trigger control, this toggle node, we drag this off and we create an input. We call this toggle 1, toggle 2, toggle 3, toggle 4. So when we send a trigger parameter to toggle 1, it flips this from close to open. And that's how we open the sound audio on that beat. So that's really important. And that's how we basically repeat this logic for all 3 spheres for the kick drum. So here the only thing difference here is toggle 1, toggle 2, toggle 3, toggle 4, and then over here the spheres. Sphere 2, sphere 3, sphere 4. We repeat this logic for all of the instruments, for the kick, for the hi-hat, and for the snare. And then that is our logic to make all of this work. So what you have now, just to recap, you have the mouse interaction, the quartz clock, and we're populating the metasounds. Then we're using a line trace so that we can control which faders by a variable is filter is volume. Then we're using a BPM time adjuster, those 2 buttons on the ground to change the BPM. We're using the event tick to update all the BPM parameters for all the metasounds in real time. We're toggling on and off the 4 beats of each kick, snare, and hi-hat based on clicking the spheres, or by clicking the boxes. We're actually turning on the instruments. We're turning on the synth. Then down here, we're toggling each individual beat of the kick, the snare, and the hi-hat. And that is pretty much it. That kind of wraps it up for how this whole thing works. Again, a little complicated, and could probably be a little cleaner if I used BP instances instead of making them for each one. But again, you know, you learn as you go. And since this is just a game dedicated to this, I wasn't too concerned about CPU resources and things like that, but this works pretty well. I've tried it at all sorts of tempos, super fast, super slow. It works great. This has kind of really opened the world up to other things that you can do with Metasounds. You know, I'm working on the mono synth, but I'm also thinking about some other ideas for some more advanced drum machine ideas and more synth. I thought about even building the TB303. I might still do that, maybe not, we'll see. But anyways, I hope all of this was entertaining. I hope that it was fun. I hope that you learned something. Again, I went really fast because if I broke this down step by step, this would be like a Udemy class series. But I wanted you to just see everything. That's pretty much all that we did. You can build this yourself. If you try building this and you have any issues, feel free to comment in the sections. I check the comments pretty regularly. Maybe I can help you out. Also, if you need some screenshots or something of this, just let me know. You can technically just stop the video, screenshot the blueprint. Feel free to use this however you want. One quick thing, the way I built these images is I just found some cool drum images and I imported those, and then I created a material out of those, and it worked really well on the cubes. And then the same with these buttons. I basically just I created some fonts in Photoshop, and I created materials for each of these buttons, and these are just kind of like boxes, as you can see. These knobs here are just balls, basically, which are pretty cool. But anyways, yeah, so that's it. Hopefully this was helpful. Got some really cool stuff in the works right now coming your way. Please like and subscribe to the channel, tell your friends, and we'll see you in the next video.